One of the tricky things in trigonometry is inverse functions. It's actually a very simple concept, but because of the notation, many students tend to get a little scared of these kind of problems. So let us do a simple problem using inverse functions now. So the question is, if A equal to sine inverse of minus 1 by root 2 plus cos inverse of minus half, B equal to tan inverse of minus root 3 minus cot inverse of minus 1 by root 3, then which of these following should be true? So, let's get to the solution. And so the first thing to notice here is that what is an inverse function? So an inverse function is very simple. It's basically the angle where if you take a trigonometric ratio of that angle, so if you do sine of that angle, so sine inverse of A is basically that angle. That is all. It is just a notation so that when you write big equations like the problem above, it makes it, we don't need to be expressing it in terms of words. You have now just said sine inverse of minus 1 by root 2. It's an angle, so you understand that. So what is that? How do we approach such problems? Especially if it is just sine inverse of a real number. If they had given sine inverse of x and cos inverse of y, then there is some algebra and more complicated things have to be done. But here, usually in such multiple choice questions, they do give you a specific value. And the key here is identifying whether that value can be used to represent it as an angle, because we would know that sine inverse of sine theta is theta. So that is the key here. So the key is to use this concept that sine inverse of sine theta equal to theta. So that is what we have exactly done here. We have looked at minus 1 by root 2 and we said, hey, 1 by root 2 is just sine 45. That is a standard value which everybody should know. So if you do that, how do I get minus 1 by root 2? That's simple. We should also know that sine of minus an angle is minus sine theta. So if you take sine of minus 45, that will be minus sine 45, which will be minus 1 by root 2. And that's what we have done. We have taken minus 1 by root 2 and we have written it as sine of minus pi by 4. Same thing for minus 1 by 2. What is 1 by 2? That is cos 60. So we know that. Okay, how do I, but what is minus, but cos of minus theta is cos theta. We can't use that. So how do we do this? But we know that cos of pi minus theta, cos of pi minus theta in this case will be minus cos theta. So we can use it. So we're going to use pi minus the theta in this case for 1 by 2 is pi by 3, which is 60 degrees. So we're going to say it as cos of pi minus pi by 3. Then, but pi minus pi by 3 is just 2 pi by 3. So we write it as cos of 2 pi by 3. Once you do that, we are now going to apply our sine inverse of sine formula. So we'll end up with just the angle, which is minus pi by 4 plus 2 pi by 3. And hence, if you just take a simple LCM, you'll end up with 5 pi by 12. So similarly, we're going to approach the next one. We're going to similarly write based on tan values. We're going to use tan inverse of tan of minus pi by 3 minus cot inverse of cot of 2 pi by 3. Where did we start from? We started from minus root 3. So we know that some of these are tan 60, which is root 3. And similarly, we use for cot. We do the same thing. Again, tan inverse of tan is just the value, so which is going to be just an angle. So we're going to end up with minus pi by 3 minus 2 pi by 3, and this will be a simple minus pi. So now we are going to substitute this into different combinations. As I said, we're going to try a plus b, and a plus b is minus 7 pi by 12, but that's not given as a choice. So we are going to end up with, we're going to try other things, and a minus b matches 17 pi by 12. Hence, A is the correct option.